Hello, this is Brinda Avadhanam. This is my video quiz submission for quiz 2, classes Chem 110 lecture. And yes, I'm filming this on a slime box. Let's get started. Number 1A, true or false, the reaction between a weak acid such as, I'm going to just underline these, weak acid and a weak base such as NH3 cannot occur because both are weak electrolytes. Okay, the reaction cannot occur because both are weak electrolytes. Okay, so I'm gonna answer false to that because I know, like, according to my learning, what I've learned, I'm thinking the reaction between a weak acid and a weak base can in fact occur, but the thing about weak electrolytes is they don't dissociate. So for example, if you took like a strong base like NaOH or something like that in a molecular reaction, when you're making it a complete ionic reaction, it would dissociate into Na plus and OH minus, but something like this, which is like weak, would not dissociate, which is why I'm saying the reaction can still occur. Now they want us to write the complete ionic equation, so I'm going to start, I don't know if we can zoom, I'm going to get started with HC2H3O2, and that is aqueous, plus NH3. Sorry if I'm going to pause a little bit because as you can see, I'm left-handed, so when I'm writing you won't be able to see it that well, so sometimes I'll just like pause it a little bit. But anyway, so then what does that create? So I think in this case what's going to happen is the H from the HC2H3O2 is going to combine with the NH3 and give us NH4 plus, which is ammonia. And then what's left is the C2H3O2, which, yeah, C2H3O2, which is a minus charge, aqueous. Okay, so that's basically our molecular, but remember what I said, I was thinking that it's not going to dissociate, so this is not going to become H plus and C2H3O2 minus. That's just not, that was a bad minus. That's just not going to happen, so we're not going to have that whole process where we look for the spectator ions and stuff like that. Instead, this is, I think, going to be our complete ionic equation. So I'm just going to draw a box around it. Hopefully that, yeah, okay, that's a good enough box. And explain why you answered true or false. So basically what I'm writing is like a bullet pointed version saying that I answered false because although weak electrolytes don't dissociate in solution, the reaction is still able to be taken. The reaction is still able to take place and produce ions. Yeah, okay, so that's my answer for 1A. Let's keep going to 1B. Consider the solution with these following ions. Okay, and then true or false, when all are allowed to react, exactly 3 different solids will form, and they want us to list out all the solids that will form using the correct formulas. Okay, so what I'm going to do is first, let me just delete that real quick. Okay, I think I'm just going to separate them into cations and anions, and my game plan is to take each anion and pair it with all the different cations, and then after that use my solubility rules to figure out which of the following are soluble and which are insoluble. So that's my plan. These are cations, and then these ones are anions. So we take each anion. First we're going to take nitrate, and I remember reading in my rules, I have the exam version of my solubility rules on my side. So I know that 1 through 3 says memorize, but I remember one of the rules was that all nitrates are soluble, and I don't think there was an exception. So this one's going to go fairly quick. PB, oops, you can't see that. Let me move it this way. PB2 plus NO3 minus gives you PbNO3 and whatever I just said, all nitrates are soluble. So this is going to be aqueous. So that's one such thing. I'm just going to do like a loose box around it. Next one is K, so potassium. K plus NO3 minus gives you KNO3, and that's also aqueous because it's a nitrate. And then lastly, for the nitrates, Ag plus NO3 minus gives you AgNO3, and that's aqueous. Yep. Okay, so those are the nitrates, done. Next up, I'm going to do the chlorides, the Cl minus. And in the rules that we had to memorize, I'm pretty sure chlorides are soluble, but there are some exceptions. So let's get to that. First thing we'll do is do the Pb2 plus. Pb2 plus Cl minus gives you PbCl2. Now, in the chlorides, I'm pretty sure lead or Pb was one of the exceptions. So I'm going to go ahead and classify this as solid. And this is going to be in red. It's the first solid we've found so far. Let's keep going. Potassium plus chloride. K plus Cl minus gives you KCl. And I don't think that was an exception. Oops, sorry. I don't think that was an exception, so that's still just going to be soluble. It's going to be aqueous. And then lastly for the chloride, Ag plus Cl minus is going to give us AgCl, and I think Ag or silver was one of the other exceptions. So this is also going to be solid. When I say exception, I mean one of the things where it's like all chlorides are soluble except for all chlorides are soluble except for like the following, and I'm pretty sure Pb was in it, and I'm pretty sure Ag was in it. Okay, let's keep it going. I don't know why I scrolled down. So we finished the chlorides. Now we're going to go on to the sulfates. There is a rule about this that I can see. Rule 6 says all sulfate compounds are soluble except, and it lists off some exceptions. So let's keep going. Ag plus SO4 2 minus gives you Ag2SO4, and let's see those exceptions. It does say silver, so that means this is not going to be soluble, and that is a solid. That means it's going to be solid. So we found our third solid. Okay, that's good. Let's see what's next. Oh yeah, the K. So K and SO4. So K plus SO4 2 minus gives you K2SO4. Now, sulfate, so since it doesn't have K or potassium as an exception for the sulfate, this is still soluble, so I'm going to go with AQ. So then what's the last sulfate is going to be Ag. Ag plus SO4. Oh, I'm so sorry. I kind of like messed up the order for some reason this time. I put Ag at the top. I was supposed to do Pb over here, but whatever, I'll just do it down here. Pb2 plus and not Ag, SO4 2 minus. So since it's 2 plus and 2 minus, it just becomes PbSO4. And if I look in my solubility rules, the sulfate compounds are soluble except for, and it lists lead. So this one is silver and this one's lead, and both of them are not soluble. So this is also going to be a solid. Now at this point, I have 4 solids, so I can confidently circle false because they asked exactly 3 different solids will form, but I've been showing you that, in fact, 4 have formed and we're not done yet. So I'm going to click false on that, and let's keep going because they wanted the full list. So lastly, phosphates. That's not a rule in the solubility rules. None of them talk about phosphates, so I'm guessing it's going to be mostly like a Rule 8 thing. And the Rule 8 says that like anything that has, any compound that has polyatomic ions that are not mentioned above will be considered insoluble. So phosphates aren't mentioned above, so I'm thinking it might just be insoluble. Let's see. Pb2 plus PO4 3 minus gives you Pb3 PO4 2. Okay, before I box that, Pb3 PO4 2. So since Pb, I have my periodic table. Since Pb is not a group 1 and PO4 2 minus or PO4 3 minus is not mentioned in solubility rules, I'm going to go ahead and say this is a solid according to rule number 8. Next up is K. So K plus phosphate gives you K3PO4. Now this one's a little tricky because ideally you would use the PO4 rule, like rule 8, and say that since it's a polyatomic ion, it's insoluble, like it has something that's not mentioned in the solubility rules. However, K is a group 1, like K plus is a group 1 ion, and in rule 8 it said except those of group 1. So I think this is going to be one of the exceptions, and I think it's actually going to be soluble, so it's going to be an AQ. So that's not a solid. Lastly, Ag plus, oh, I'm running out of room, Ag plus and PO4 3 minus gives you Ag3 PO4. Kind of like what we said with the Pb with the lead. Since Ag is not a group 1 anything and PO4 is not mentioned in the solubility rules, we can use rule 8 and say that that's going to be insoluble. So that is going to be a solid, which is red. So as you guys can see, 1, 2, 3, 4, 5, 6. So we've gotten 6 solids. That's why I'm saying that this is false. That was really messy, I'm sorry. Okay, let's move on down to 1C. True or false, when a strong acid and a strong base react, only water is formed. Only water is formed. Thus, no net ionic reaction can be written. Okay, so I already am leaning towards false because it's using language like only water is formed and also like no net ionic reaction can be written. I agree that when a strong acid and strong base react, everything dissociates and only water is formed. That makes sense. However, I don't believe that that means you can't write a net ionic reaction. I think you can still write your net ionic reaction. So I'm already leaning towards false, but let's go ahead and do what they said for the explanation, which is choose a strong acid other than HCl and a strong base other than NaOH and write out your molecular and your complete. Okay. I'm just gonna like make a table, I guess. Ooh, I'm so sorry. I think I moved the thing. Okay. Anyway, yeah. So, what's a strong acid other than HCl? I like bromate, so I'm gonna, or not bromate, sorry. I like bromine, so I'm gonna go with HBr. I'm gonna be really embarrassed if that's not a strong acid. And then a strong base other than NaOH is KOH. I like KOH. Yeah, okay, KOH. So strong acid, strong base, what happens? So the OH, the hydroxide, mixes with the hydrogen and it gives you H2O in liquid form. H2O, and what's left is KBr. And I know for a fact that's aqueous because one of the rules says that like all the chlorides, bromides, and whatnot are soluble, and then potassium is not an exception for that. Now, complete ionic. So everything breaks down because it's a strong ion, or it's a strong electrolyte, both of these. So they do dissociate into their own respective ions. H plus. I'm just not going to write AQ on the ones that are aqueous, but I will label whatever's not aqueous because I don't think I can fit everything in it. Br minus, K plus, OH minus, H2O stays H2O because it is not aqueous, it's a liquid, but K dissociates and Br dissociates. Now, they want to know if no net ionic reaction can be written. I believe that's false. Because the spectator ions in this case are K plus, right? And Br minus. So if I wanted to, once those are taken out, my net ionic reaction would just be H plus plus OH minus gives you H2O liquid. So I really don't get why they're saying that no net ionic reaction can be written. I think this is the net ionic reaction that can be written. So I'm going to go with false on this. That's my explanation. Okay, that's part 1. Oh, no, we're still on part 1, sorry. Part 1, question D. True or false, platinum ions cannot be reduced to platinum solid by any other metal on the activity series because it is near the bottom of the activity list of metals. If true, explain why. If false, write out an example of a reaction that could occur within platinum ions to reduce them. Be sure to explain which species is reduced and which is oxidized. Sorry, I read that completely wrong. Okay, let's see here. Platinum means it's down here. Took me a second to figure this question out. So they're saying true or false, it can't be reduced to solid because it's at the bottom. I believe that to be true, and I have to explain why. And then if it's not true, write out an example. So I think it is true because, why do I think it's true? I think it's true because the closer you are to the bottom of the activity series, the less reactive the metal is. And like, since it's unreactive, it's not going to be able to be reduced into a solid. Yeah, because platinum ions cannot be reduced to platinum solid. That means this would have to be flipped, but it wouldn't do that because it's very unreactive, so that wouldn't happen. So I'm going to say true because platinum is at the bottom of the activity series. Bottom of the activity series. This means it's unreactive. It can't